Welcome to qnawire.
In the given figure, which angles must have smaller measures than the measure of angle 1? In this example, we need to identify angles in the diagram whose measure is less than that of angle number 1, but we're not given the measures of any of the angles. So to solve this, we'll need to use the diagram and the relationships between angles in triangles. In particular, we recall that the measure of any exterior angle of a triangle ABC, for example CBD in our diagram, is greater than the measure of either of the non-adjacent interior angles of the triangle. If we label all the vertices in the given diagram as shown, we see that angle 1 is an exterior angle in the triangle ACD. Hence its measure is greater than those of the two non-adjacent interior angles in this triangle, and these are angles 4 and 5 at A and C respectively. Now we need to pay careful attention to the wording of the question at this point. Note that the question asks which angles must have smaller measures than that of angle 1. So far we've demonstrated that this is true of angles 4 and 5, and we can show via an example that the remaining angles may not necessarily in certain circumstances have a measure smaller than that of angle 1. Suppose our triangle ACD is an isosceles triangle, and that the measure of angle 1 is 60 degrees. We can add any line we like from D to a point B opposite D to construct the missing angles. But since our triangle is isosceles, we can use the fact that the angle bisector and perpendicular bisector of the base are the same line. We see then that the measures of angles 6 and 7 in this scenario are both 90 degrees. Which is greater than 60 degrees, and that's the measure of angle 1. So these two angles can have measures that are not smaller than that of angle 1. Next we know that the line DB bisects the angle at D, so that angles 2 and 3 have the same measure. We see also that angles 1, 2 and 3 combine to make a straight angle, so that the sum of their measures is 180 degrees. Now substituting 60 degrees for the measure of angle 1 and recalling that angles 2 and 3 have the same measure, we can solve this to find either of the measures of angle 2 or 3. Choosing angle 2, we have its measure equals 60 degrees, and of course we know that this is also the measure of angle 3. So both of these are equal to the measure of angle 1, and we've therefore shown that angles 2, 3, 6 and 7 need not have smaller measures than angle 1. Hence, only angles 4 and 5 must have measures smaller than that of angle 1.